Welcome to lesson 8.2.2. Today we're going to be talking about the product rule. There are 2 video lessons in this section, so this is the first one. Here is your to-do list. You can make a copy of this. You can keep it right in here. We have encouraged you to download this. It's on your list of things to do. You are going to be watching a video, which you're doing right now, taking some notes, and the 3 indented lines after that, definition, examples, and your problem with a solution, are example of the notes that we're hoping you'll take. Then you'll have an RMP and some learning extensions that'll have to be completed. You can either download the note template, or you can take your notes in your classwork notebook as you go along. Either way, just please make sure you have all of that to show me when you complete this. Take a minute and read your learning targets. I understand what the base and exponent represent. That is something from our last video, 8.2.1. And I can simplify numbers with exponents using the product rule. Before we get started, let's take a look at some actual information. So if we have these 3 boxes and we start at the very beginning and we look at 3 to the power of 5, our question is that the same as this one right here, as 3 times 5? Well, 3 to the power of 5 is definitely not the same as that. So we would say no, because 3 times 5 is 15. And we are assuming that 3 to the power of 5 is much larger than that. So if we take a look at our next box, what do we have? We have 1, 2, 3, 4, 5 3s being multiplied. Remember, our base is what are we multiplying, and our exponent is how many times. So the pink and the green, they are actually the same. And 3 times 3 times 3 times 3 times 3 is actually equal to 243. So what we're going to do now is we're going to use some information, and we're going to try to develop the idea of what the rule, the product rule, is. So thinking about the fact that we're having 5 to the power of 2 and we're multiplying that by 5 to the power of 5 product, multiplication, the answer to a multiplication problem is the product. So 5 to the power of 2 is 5 times 5, and then 5 to the power of 5 is 5 times 5 times 5 times 5 times 5 times 5. So how many 5s do I have in total? I have 7 of them. So this becomes that. So let's expand it out one more time into our factored form. So I have 2 to the power of 2, that's 2 times 2. And then I have 2 to the power of 4, so that's 4 2s. And then I want to know, how many 2s do I have in total? Well, I have 2 and I have 4, so 2 plus 4 is 6. Let's keep going. 3 to the power of 7. 1, 2, 3, 4, 5, 6, 7, and then 3 to the power of 2. How many do I have in total? I have 7 here, plus 2 more. That gives me 9. So that ends up being 3 to the power of 9. Have you come up with a rule? That's the question. Let's try the next one. If I have 3 x's, and then I have 5 x's, 1, 2, 3, 4, 5. If I have 3 plus 5, I have x to the power of 8. So that's our basics. And now what we're going to do is we're going to make it a little bit more challenging. We're going to kind of add a few things and see if you can figure out what the rule would be when you are adding something other than just this, or multiplying something other than just the same base. We're going to expand it out just like we did on the 4 problems above us. So if we have x to the power of 3, that's x times x times x times y squared, y times y, times x times y squared, y times y. All right, let's count up our x's first. I have 1, 2, 3, and then 1 more. So I have x to the power of 4. And then if I was going to be counting up my y's, I have 2 and I have 2. So then I would have y to the power of 4. Let's try it again. If I have 7 squared, that means I have 7 times 7. And then I'm going to change my marker. And then if I have x to the power of 3, x times x times x. And then I'm back to my 7s, just one of them. And then I'm back to my x's. So how many 7s do I have? 2 here and 1. So I have 7 to the power of 3. And then how many x's? 3 and 2. And then I have x to the power of 5. All right, last but not least, let's do this last problem and see what nuances we find here. Okay, so let's start with the number 2. So we have 2. Then we have our x's. We have 4 of them. And then we have 3. Hard to see that 3. And then we have another x. Then we have y's. All right, well, let's put it together. So I have 2. And then if I look at my x's, I had 4 plus 1. So I have x to the power of 5. Then I have this 3. And then I have y squared. So the big question is, if you take a look at the 2 and the 3, they're not exponents. They're just numbers. So what we want you to think about is, since there's no exponent, they're not bases, they're just numbers, so they can be multiplied. So this entire thing simplified would be 2 times 3, which is 6, and then x to the power of 5. I better fix that. X to the power of 5. Sorry. X to the... I'm failing miserably here. X to the power of 5. And then we have y squared. And this right here is where we are hoping to get you to. As you can see, this is a note page. What is the product rule? Well, the product, the answer to a multiplication problem is called the product. So if the answer to a multiplication problem is called the product, this would be the product rule. The rule for multiplying like bases is this. You keep the base and you add the exponents. That is your rule. So here are some actual problems. I would ask you to write down some of them as your notes, as examples in your note-taking, whether it's in your classwork notebook or on our note sheet. I would also ask you to pause the video and then come back and check your answers. So hopefully you're back. We have like bases, so we keep the base and we add the exponents. We have 4 plus 8, that is equal to 12. So our answer would be 3 to the power of 12. We have like bases, so we keep the base and we add our exponents, 7 to the power of 8. We do not have like bases here. We cannot combine anything. The answer to this problem is exactly what we started with. 4 to the power of 8, 7 to the power of 10. This is a very similar problem to our table. So just showing you that it is absolutely the same rule when our base is an exponent. We keep the base and we add the exponents. So here are some more problems. These could also be notes if you wanted them to be. They could also be examples, up to you. So pause the video and give them a try. So welcome back. So we have a like base of 2 and 10 plus 4 is 14. We have a like base of x, and 8 plus 5 is 13. We have different bases, but we do have x's that are the same. So we keep the x base, we add those exponents, and then we just have the y. We keep the base, which is a 6. Please remember that there's a 1 there. So this would be 6 to the power of 4, and then here is the x's. X to the power of 9. All right, going back one more time to this idea of if something does not have an exponent, it is not considered an exponential part of the problem. So for this, you're just going to bring these two down. You're going to have 2 times 3, kind of like combining like terms, if you will. And then you're going to have x to the power of 2 and then x to the power of 4. And when you simplify that, you get 6, and then x to the power of 6. So breaking the problem down like I just did is really helpful if it is at all confusing for you. So this is the last part of this first section of the product rule. So at this point, you would want to make sure you have all of your notes and a complete understanding, and you would want to come up and get the RMP from Ms. Brewer.